Section 1.2 is going to be variables, expressions, and equations. So we'll start off with a couple definitions here. The first definition is going to be a constant. So a constant is just a fixed or unchanging number. So for some examples of these would be just normal numbers like 5 3/4, 8 1/2, 10.8, and so on. So those are constants. They're just fixed numbers. They're never changing. They always mean the same thing. A variable is going to be a symbol, which we're pretty much always going to be using a letter, which represents an unknown number. So something like A, X, Y, Z, these would be variables. And an algebraic expression is going to be an expression which consists of variables, constants with the operations like addition, subtraction, multiplication, division, as well as powers or roots. So an example of some algebraic expressions, something like x plus 5 is an expression. 2m minus 9 is an expression. So that's 2 times m. And something like 8p squared plus 6 times p minus 2 is also an expression. Okay, so there's no equal signs in expressions. So let's work on evaluating algebraic expressions. So to do this, we're going to be given a value for the variable. We're going to have to plug it in. And then we just have to make sure we're following the proper order of operations. So let's evaluate these following examples. So let's do 2x minus 7 when x is 3. So what we're going to do is we're going to plug in a 3 into x. It's pretty good practice just to keep parentheses around them. So now order of operations, multiplication first. So 2 times 3 is 6. 6 minus 7 is -1. Okay, next one we have 3x plus 4y. And the x is going to be 5 and the y is 4. So let's plug in a 5 into x, a 4 into y. So we have 3 times 5 plus 4 times 4. So order of operations, we do the multiplication first here. 3 times 5 is 15. 4 times 4 is 16. 15 plus 16 is 31. And they'll get a little messier. So the next one, 9x minus 8y over 2x minus y. For x equals 1 and y equals 2. So plug in a 1 into the x's. So there's 2 x's. So it's going to be 9 times 1 minus 8 times y, which is 2, over 2x minus y, so 2 times 1 minus 2. Actually, for a reason which I just saw, I'm going to change the y to a 3. The reason why I'm doing that is because the denominator would have been 0. So I'm going to plug in a 3 into y instead. So I'm just changing those ones. So it's going to be 9 times 1. So I'm going to do the numerator and denominator separately. 9 times 1 is 9. 8 times 3 is 24. And then 2 times 1 is 2. So 2 minus 3. So we have 9 minus 24, which is -15. 2 minus 3 is -1. -15 divided by -1 is the negatives cancel, and that's just equal to 15. Next one, x squared minus 2y squared when x is equal to 4 and y is equal to 3. So plugging in 4 into x with parentheses and 3 into y with parentheses. So we do the exponents first. 4 squared is 16. 3 squared is 9. 16 minus 2 times 9, multiplication next. 2 times 9 is 18. So 16 minus 18 is -2. Okay, so something that's pretty important that I don't want us to get messed up is this next page here. when we raise a negative number to an odd power, it's going to result in a negative number. When we raise the negative to an even power, it's going to result in a positive number. And this is going to be because a negative times a negative is a positive, and a negative times a positive is a negative. So we'll see kind of why that is and what happens when we do these examples. So let's evaluate x squared when x is negative 2. So plug in a negative 2 with parentheses. So negative 2 squared, so it's to an even power, so we know it's going to be a positive answer. But I'm going to write this whole thing out. So negative 2 squared is negative 2 times negative 2. Negative times a negative becomes positive. 2 times 2 is 4. Okay, and then for x cubed, we evaluate x cubed for x equals negative 3. We plug in a negative 3. So negative 3 to an odd power, we know our answer is going to be negative, but I'll write the whole thing out. So this is negative 3 times negative 3 times negative 3. Negative times a negative is positive, times another negative is negative. 3 times 3 times 3 is 27, so negative 27. So you can probably see here, when you have it raised to a negative to an even power, the evens are going to be in groups of 2, making the negatives become positive. When a negative's to an odd power, they're going to be in groups of 2, always with 1 left over, making the whole thing negative. So let's do x to the 5th for x equals negative 1. So that's negative 1 to the 5th. So you could write this whole thing out. What I'm going to do is recognize that it's an odd power, so it's going to be negative. And then 1 raised up to any power is 1, so I'm just going to say it's negative 1. So negative 1 to the 50th power would be positive 1, because 50 is an even number, and it was an even number. So let's say we have x to the 4th for x equals negative 2, so plug in a negative 2. So negative 2 to the 4th, once again, you can write the whole thing out. Negative to an even power is going to be positive. 2 to the 4th is 16, so this is positive 16. And then we have x plus 4 squared minus 3 when x is negative 5. So negative 5 plus 4 squared minus 3, we just have to be careful with the order of operations. Parentheses first, that's negative 1 squared minus 3. Negative 1 squared, negative 1 times negative 1, positive 1, minus 3, negative 2 is our answer. Last one here, 2 times negative x minus 3 cubed when x is equal to 1. So that's going to be 2 times negative 1 minus 3 cubed. Negative 1 minus 3 is negative 4. Negative 4 cubed, negative 4 times negative 4 times negative 4. It's going to be negative 64. We knew it was going to be negative because negative to an odd power. 2 times negative 64, negative 128. So I'm going to put a little note here. If we have something like negative x and then squared, that's equal to negative x times negative x. The x's cancel, and it's just equal to x squared. But if we have something like negative x squared without parentheses, this is going to be negative. So you can write it as negative and then the x squared. So this, call this number 1, call this number 2. So they are not the same things. Okay, next thing is going to be equations. So an equation is going to be formed when an equal sign is placed between two algebraic expressions. So something like, for example, x plus 4 equals 11. It's an equation because we have an equal sign. There's a expression on the left, expression on the right of the equal sign. And maybe something like 4p plus 1 equals 25 minus p. So expression on the left, expression on the right, equal sign. we have an equation. So when we're solving equations, to solve an equation means we're finding the value of the variable that makes the equation true. And that value that makes the equation true is called the solution. So the value of the variable that makes the equation true is the solution. So for this next thing, before we start getting into solving them, let's start by identifying which are solutions to equations. So let's decide whether the number given is the solution to the equation. So the first one, we have 5p plus 1 equals 36. So 5 times something plus 1 equals 36. We're seeing if that p value is 7. So we're going to plug that in and see if it's true. So 5 times 7 plus 1 equals 36. I'm going to throw a little question mark over the top because we're trying to see if it's true. So 5 times 7 is 35 plus 1. So 35 plus 1 does equal 36. So yes, this is a solution. Next one, 9m minus 6 equals 32 when m equals 4. So we're going to plug in 4 into m. So 9 times 4 minus 6 equals 32. I'm going to put a little question mark. That's going to be 9 times 4, 36. 36 minus 6. 36 minus 6 is 30, which is not 32. So this one's going to be no. This is not a solution. Put not a solution. Okay, that did not work. And for the last thing here, so those were just as easy as plugging in and seeing if it was true, just making sure you're following order of operations. Last thing here is converting from a kind of like a word problem, translating phrases to expressions or equations. So when we're doing that, I have some commonly used phrases and then their mathematical operation. If you see the phrase is or is the result in, that would be the operation equals. If we see more than or increase by, that would be addition. Less than, decrease by is going to be subtraction. Of, times, or product is multiplication. Equal parts or divided by is division. So let's see how that works with these questions. So let's translate all of these phrases to expressions or equations, and we're going to let x be the variable here. Okay, so for the first one, it says 1/7 of a number. So we see the word of, that means multiplication. So this means 1/7 times a number which we're calling x. So this is an expression because there's no equal sign. Next one for B, we have 1/3 of a number increased by 5 is half that number. Okay, so for this one, we see of, we know we're multiplying. We see increased by, that's going to be addition. Is equal to, half is going to be 1/2 times. It could say half of that number. So we're going to start with 1/3. 1/3 of x. This is where it gets a little bit tricky, which we'll see the difference between this one and the next one. 1/3 of a number increased by 5. This means we're doing 1/3 of the number that is already increased by 5. So we need parentheses around the x plus 5. And then we'll see in the next one what the difference is. So 1/3 of a number increased by 5 is equal to half of that number. So 1/3 times x plus 5 equals 1/2 x. And this is an equation because we have an equal sign. Okay, and then for C, so we can see the difference here, we have 1/4 of a number decreased by 7. So we see of, multiplication, decreased by, subtraction. So we have 1/4 of a number. So this time the difference is this comma. It's essentially 1/4 of the number, and then it is decreased by 7. So there are no parentheses for this one. So that comma means no parentheses. And this is an expression because there's no equal sign. Okay, and then the last one here, the product of 2/3 and a number. So product is multiplication. We have a comma, so I'm just going to circle that for now. Increased by 6 is addition. We have another comma. Is, so equal to, 3 less, subtraction, twice that number, twice is multiplication. Okay. So we have the product of 2/3 and a number. 2/3 times a number, so comma, so no parentheses here, and then increased by 6, so plus 6, is equal to 3 less than twice the number. So you have to be a little bit careful here. It's not 3 minus 2x, it's 2x minus 3. So it's 3 less, meaning we're subtracting 3. Twice the number is 2x. So you have to be a little bit careful. Okay, and then this is obviously, once again, an equation because we have an equal sign. Okay, so that is it for section 1.2.